right, so this section is section 3.1. This will be the last unit that we're going to do. And this unit focuses on polynomials, rational functions, and then a little bit of radicals at the end. So today we're just going to talk about polynomials just kind of in general and just give you some important information. There's going to be a lot of good stuff for you to put on your formula sheets as we go through today. So as you come across something like, oh, hey, that's kind of important, you might want to just have that sheet out. You can be jotting things down as we go. All right, so a polynomial function is written in this form. It has some coefficient and then x to a power, another coefficient x to a power, and so on and so forth, all the way down until you get like a coefficient and then x squared, coefficient of x, and then just a constant coefficient at the end. And so the only conditions here, and I know this is written really weird, is that these powers have to be integer powers, and more specifically, they have to be positive integer powers. And so you'll see like x to the 5th, to the 6th, 7th, 8th, 9th, 10th, 3rd, right? But you're not going to see x to the negative 2nd or x to the negative 3rd. Those are going to fall into a different type of function. All right, so here is the first question. And pretty much all of these questions come from My Open Math. And so what this says is it wants the degree and the coefficient for each of the 5 terms, and then it wants the leading coefficient and the degree of the leading term, and then the degree of the polynomial in general. And so when it just says list them like this, it's just saying in order as they're written. They're not currently written from highest to lowest powers, and that's okay. They just want the first term is the one in the front, the second term, third term, so on and so forth. So you don't need to do any rewriting here. Just go ahead and tell what those terms are. Let me see if I can make it stop adjusting so much. All right, we'll see if that helps a little bit. Okay, so the first term is literally the term in the front. The degree is the power on that term. So it's x cubed, so you're just going to put a 3. You don't put an x in there, just the cube. And then its coefficient is a positive 2. The second term, that's this 8x to the 4th, its degree is 4. Once again, you do not put an x in there. The degree is merely just the highest power, or the highest power on that term, the power on that term. And then the coefficient is the number in front, so positive 8. This right here, the plus 8, technically that's 8 times x to the power of 0. Anything to the 0 power is 1, and 1 times 8 is 8. So that's where that term is coming from. So its degree is 0, and its coefficient is a positive 8. The fourth term, its degree is 2, and then its leading coefficient is a negative, and if there's not a number written there, it's a negative 1. And then the last term, the degree, the power on it, just an x, is x to the first, and its coefficient is negative 7. All right, this last set of questions is talking about the leading coefficient, degree of the leading term, and degree of the polynomial. In order to answer these questions, you need to think about it in the correct order. The order is going to matter here. So if you look at all of these terms, you're going to go based off the one that has the highest power. And so we're going to pay attention to this 8x to the 4th. All of this information here comes from that term with the highest power. So the other powers, they're impacting this, but this one, the x to the 4th, is having the most impact on this polynomial. So the leading coefficient, that's going to be 8. The degree of the leading term is 4, which means the degree of the polynomial is 4. So whatever the degree of that leading term was, the one with the highest power, that is the degree of the polynomial. All right, so up next it says find the degree, leading coefficient, and maximum number of real zeros of the polynomial. So the degree and the leading coefficient, you have to think about it in order. If it's not written in order, you need to put it in order. If you put it in order, the one that comes in the front is going to be that guy right there. It has a power of 5, so it would come first. So all of these questions are based off of just that term. These are impacting it in some format, but they're not having an impact on the degree, leading coefficient, or zeros. So the degree would be the highest power, which is 5. leading coefficient, that's a positive 3. And then the maximum number of real zeros is equal to your degree. And so what we're saying is that the number of times that this has a 0 is another word for x-intercept, the maximum number of x-intercepts this polynomial has is 5. So it is at most going to cross the x-axis 5 times. It could cross 4, it could cross 3, it could cross 2, it could cross 1, it could cross 0, just depending. It has all of the possibilities below it, but the maximum number it could cross is 5 times. If it is an x to the 5th, then it cannot cross 6 or 7 or 8 times. It is just not possible. It is 5 or lower. All right. So another thing to talk about is the end behavior of these functions. And we talked about end behavior of polynomials in Algebra 2. So this, you might not remember it, but it's not new. And so end behavior is talking about what's happening at the ends of these curves. And so there's a lot of like crazy stuff going on in here. What this is saying is as x approaches negative infinity, that would imply the left-hand side, what's happening on the left. And as x approaches infinity, that is talking about what's happening on the right-hand side. And so on the left and on the right, your graph is either going to be going up, going down, and they could either both be going up, both be going down, as we'll see. And the next one, they could be going opposite directions of each other. And so if you see x approaching negative infinity, they're talking about the left. As x approaches infinity, they're talking about the right. And then for these other ones, whenever you see f of x approaching infinity, they're saying that the graph is going up. Whenever you see f of x approaching negative infinity, that means the graph is going down. And so what we're going to do is we're going to say, hey, what's happening at the ends of these graphs? And at the ends of the graphs, it all depends on the degree and the leading coefficient. So if the degree is even, then the two ends are going to go the same direction. They're either both going up or they're both going down. So for both of these, you have an even degree. If they're both going up, that means your leading coefficient was a positive number. If they're both going down, the leading coefficient is a negative number. And so the positive versus negative here will depend on both up versus both down. All right, if your degree is odd, then what's going to happen is they're going to go opposite directions, your ends are. And so I always remember odd, opposite, they both start with O. So if I have an odd degree, I'm thinking they're opposite of each other. And then once again, it just depends on the leading coefficient. If the leading coefficient is positive, which is what this means, greater than 0, positive, it's going to go down on the left side and up on the right side. And if your leading coefficient is negative, it's going reverse of that, up on the left and down on the right. And that's what it says here. So this is saying on the right or on the left, it's going down, on the right, it's going up. And then on the left, it's going up, and on the right, it's going down, is how we would read those. So it's just a lot of symbols that kind of help us get through those. All right, so I have an example of some end behavior that you would see in my math. All right, so this first one is a negative x to the 6th. So the first thing we need to talk about is the fact that that highest power is even, and then the leading coefficient is a negative. And so we're going to talk about what is happening on each side. This is the left because of the negative infinity. This is the right, and we're going to say whether it goes up infinity or down negative infinity. So if you need to draw a quick picture of what's going on, that's fine. If it's even, then the two ends go the same direction. And when it's negative, the two ends go down. So both the left and the right will be going to negative infinities. Make sure you see those negatives. They're both going to negative infinities. All right, your next one its highest power is 7, and 7 is a odd number, which means that your ends are going opposite directions of each other. One's up, one's down. And then the number in the front is 3, and what we really care about is that that is a positive. And so if you need to go back to your chart for odd and positive, it's going to go down on this side and up on the right. So this will go down and, it's kind of drawn weird, sorry, down and up like that. So this is saying as n goes to negative infinity, that's the left. Well, on the left, it's going down, so we'll say negative infinity. As n goes to positive infinity, that's the right. This one is going to positive infinity. Just remember, if your variable is going to negative infinity, that's the left. Positive is the right. Left, right, left, right. So what's happening on the left? What's happening on the right? All right, the last one, we have an odd power there of 7. The number in front is a 1, and that's a positive 1. And so this is actually the same as the last one. It is going down on the left and up on the right. So when it says x goes to negative infinity, that's the left. So that would be negative infinity as well. And as x goes to positive infinity, that's the right. This goes to positive infinity. All right. End behavior would be a great note of some kind. You don't have to write this all out exactly, but some kind of note on your formula sheet so you know exactly which way they're going, especially for the odds. The even ones aren't too bad. Mainly the odd ones that are a little tricky, I would say, to remember which one's which. All right, so here is the next question. It says, given the function f of t, and then it tells us what f of t is, there are at most blank x-intercepts. That's the same question that we saw when it said there's at most, like what's the maximum number of real zeros. And so based off of the equation here, the highest power is 10, which means that at most there are 10 x-intercepts. So this graph can cross the x-axis 10 times. It can cross anything below 10 as well, just depending on the setup. And we would actually have to get into some algebra there to figure out how many exactly, but at most 10. So it can't cross 11, can't cross 12. It can cross 10 times or less. The next part of this is talking about turning points. And when they talk about turning points, they're talking about turning points in your graph. So for example, if this graph starts up here and it does some loop-de-loos, really they're just kind of like swivels, right? Let's say this is the graph. We can figure out, right, how many times it crosses the x-axis. The turning points are the maximums and minimums. How many times does the graph change direction from going positive to negative and vice versa? And so there's at most 9 turning points. Turning points is always the degree minus 1. So whatever your degree was, which was 10 in this case, subtract 1, it means that the graph can have 9 places where it changes direction. That is the most, no more than 9. It could have less than 9, it could have more than 9, but at most 9. That would be a good thing to add. Turning points is pretty basic, but if you don't remember, especially when you're working on homework or taking a test or whatever, if you don't actually remember how to figure out the number of turning points, there's not really anything that's going to give it away except for knowing. You just got to know it's the degree minus 1. All right, next 2 questions are going to talk about an equation, and we want to know the least possible degree for the polynomial. And so one thing you could look at is you could look at how many times it crosses the x-axis, right? Well, unfortunately, this one doesn't cross the x-axis at all, so that doesn't really help me in terms of determining its possible degree. But what is going to help is the number of turning points, because turning points is the degree minus 1. So how many times does this turn and change direction? Well, it does once here, once up here, and once down here. So there are 3 turning points, which means the degree has to be one more than that. So the least possible degree of this polynomial is a degree 4. It could be higher. We're not 100% sure, but the least possible degree is degree 4, the turning points plus 1. So degree minus 1 is turning points, or turning points plus 1 is the degree. All right, looking at the next one, what's the least possible degree of the polynomial graphed above? Well, this one does have x-intercepts. It crosses twice. So we know that. So there's a good chance that the degree would be 2. It has to be at least 2. It can't be anything less than 2 because it crosses twice. Another way you could look at it is the number of turning points, like we did the last one. In terms of turning points, this has just one turning point, which would imply its degree would also have to be 2 in that case, right? Because its turning points plus 1 would be degree. So we're going to say the least possible degree here is 2. All right, we're going to go ahead and try to start finding some x-intercepts where it crosses the x-axis. We are also going to find y-intercepts where it crosses the y-axis. And we're going to still talk about zeros. We're still going to talk about end behavior. We'll talk about some multiplicities here in the next little bit. And really, we're just going to kind of sum up some graphing in general. All right, so given the function g of t equals t minus 6 times t plus 4 times t minus 7, the g-intercept is blank and the t-intercepts are blank. And so this is a little bit more complicated because of the g and t. If you think about it though, the t is in replace of the x. So if you need to label this as x-intercepts so you know what you're looking for, please do that. The g-intercept, that's this piece here, and that's what is replacing the y in the equation. And so the first piece of this is asking for the y-intercept. The second piece is asking for the x-intercepts. And so this is something you might want to put in your notes. How do you find a y-intercept? You plug in 0 for your x. Every x, plug in 0. In this case, they're not x's, they're t's, right? But you're just going to plug in 0. So it'd be 0 minus 6, which is negative 6, times 0 plus 4, which is 4, times 0 minus 7, which is negative 7. Multiply those out, you're going to get negative 168. And so because it's asking for an intercept, my open math wants it as a coordinate point, 0, negative 168. Remember, anytime it asks for an intercept, it absolutely positively wants it as a coordinate point. So if you just put in negative 168, it's not going to mark it right for you. So make sure your coordinate point. And it does have, you do have to put the parentheses, right, for a coordinate point. All right, t-intercepts, those are x-intercepts. And that's where the function equals 0. So you're not plugging in 0 this time. You're figuring out where does this equal to 0. And because it's in factored form, it's really easy to see your x-intercepts in this case. It's what number makes each of the factors equal to 0. So what number do you have to put in there for this factor, t minus 6, to be 0? And you only have to plug in 6, right? 6 minus 0 is 0, so that will make this 0, which will make the whole thing equal to 0. This next one, what number do you plug in for that t? So that you add 4 and get 0, well, you just change your sign, right? Negative 4. And then last but not least, what do you plug in for that t? That would be a positive 7. So it crosses the x-axis at 6, negative 4, and positive 7. And for the x-intercepts or the t-intercepts, they want you to list them as coordinate points. So 6, 0, negative 4, 0, and 7, 0. So make sure somewhere in your notes that you know the difference between finding a y-intercept and finding x-intercepts. We're going to talk more about them in the next few examples. So we're not done yet. All right, so to find the f-intercept, that's what they're talking about in terms of the y-intercept. And then the t-intercepts, those are your x-intercepts. And so if you're going to find the y-intercept, remember you plug in 0. So when you plug in 0 in here, we're going to figure out what we have. Well, 0 to the 4th is 0 times 4 is 0. 0 cubed is 0 times negative 8 is still 0. So you can say, all right, that'll be a plus 0 or minus 0, however you want to think about it. And 0 squared minus 0 is still 0. And 0 plus 0 plus 0 is 0. So your y-intercept is at 0, 0. It goes through the origin. By the way, if 0, 0 is a y-intercept, it also has to be a x-intercept. Important piece of little information that can help you out there. There are more, but at least we know one. So if you have a y-intercept at 0, 0, your x-intercept is for sure at 0, 0 as well. All right, to find the rest of the x-intercepts, we're figuring out what makes that equal to 0, the entire equation equal to 0. And most likely, you're going to want to try to factor if possible. And so this does factor. It starts off with a GCF. They all have something in common. They all actually have a 4 in common, so we can take out the 4. And then they also all have some t's. This is t to the 4th, t third, t squared. So you can take out a t squared and write what's left over. So if you take a 4t squared out, you would have t squared minus 2t, and I'm going to go with minus 15. 60 divided by 4 is 15. And we're still figuring out where that's equal to 0. This piece right here will factor. Two numbers that multiply to be 15 add up to be negative 2. Negative 5 and positive 3. Still equal to 0, and you still have the 4t squared in the front. So now that it's all factored, what makes these equal to 0? Well, the first one that you shouldn't forget is the fact that you do have a t on the outside. So that's 0, and that's where this one comes from the front. This one's when t is 5, and that one is when t is negative 3. Just change your signs. So we would have 5, 0, and negative 3, 0. All right. Next one, find x-intercepts and the y. It says f of x-intercept. By the way, the f of x-intercept, that is just your y-intercept, right? And this one's in reverse, so don't be fooled. The other two, they were reversed on our paper. So if you want to find the y-intercept first, that's fine. Plug in 0. This would be 0 cubed, which is 0. So that'd be what? Negative 0, which is just 0. Plus 3. So it crosses the y-axis at 3. So that would be the coordinate point 0, 3. All right, in terms of the x-intercept, you are trying to figure out where it is equal to 0 at. Now for this one, in terms of factoring, I don't see anything that they have in common. They don't have a number in common. They don't have an x in common, so there's not really any factoring that I can do. It's not a quadratic, so quadratic formula is out. One interesting thing about this, though, is it only has one x, right? And so all those extra x terms are missing, like there's no x squared, there's no x by itself. And so because those are all missing, you can actually just go ahead and do the algebra to solve this. So the first thing you can do is move the 3 over, so subtract 3 from both sides. They both have negatives in the front of it, so you can divide them both by negative 1, which will make them both positive, so x cubed equals positive 3. And then you can get rid of the cube by taking the cube root. So x would be equal to the cube root of 3. And you don't have to put the decimal on there because that would just be rounding. So just leave it as the cube root of 3. Also, you don't need plus or minus because this was a cube, which was odd, and not a square root or a fourth root, not an even root. And so this actually only crosses the x-axis once. It's at the cube root of 3, 0. All right. Next one, we have P of X equals, and it's already in factored form, which is actually really exciting because that means we don't have to do any factoring or anything, right? And it wants the y-intercept first. So y-intercept, you plug in 0, right? So if you plug in 0, you'll have -5 times +8 times -2. And so that is 80. Right? Did I do that right? Yeah, 80. So then your y-intercept is at 0, 80. The zeros are another word for x-intercepts, right? So whenever you see zeros, it's saying x-intercepts. It wants you to list them, but then it says this. And what that means is it wants you to put them in order from smallest to largest. So on the other ones, it said, hey, just list them. But on this one, it's saying put them in the specific order from smallest to largest. That's what that inequality means in terms of x1, x2, x3. And so your x-intercepts are at +5, -8. And then this one, the 6x minus 2, you might have to get a little creative with that. If you're not sure what number makes it equal to 0, set it equal to 0 and solve it. You would add 2, divide by 6. So this would be 2 divided by 6, which is 1 divided by 3. And then just order them from smallest to largest. So the smallest is -8, then a third, and then +5. All right, up next, this is talking about end behavior. Whenever you see x goes to infinity, x goes to -infinity, it's talking about the ends. Infinity is the right side, -infinity is the left. And if it helps you to think about the x's, right, this is your x-axis. Over here is where positive infinity would be, and over here is where negative infinity would be. And so that's why it's the right and the left. Positive infinity, negative infinity. So we, in order to figure out where these ends are going, we need the degree and the leading coefficient. And so in order to find that, you should multiply this all out and then take a look at the highest power. If you need to multiply it all out to do this, by all means, go for it. But you should kind of pick up on what's going to happen. If you have x times x, and then that gets multiplied by a 6x, that's going to be a 6x to the third, right? And that is going to be your highest power and its leading coefficient. So it's the x, and the 6x. Those will all combine to be that leading coefficient term, the one in the very, very front. So the degree is 3, which is odd. The leading coefficient is 6, which is positive. And if you need to flip back, I have it right here. Degree is odd, leading coefficient positive. It's down on the left, up on the right. So it's going down over here, up over here. So on the right, it's going to positive infinity. And then on the left, it's going down. So that would be a negative infinity. All right. Up next, we have another function. It says its roots. By the way, roots is another word for zeros or x-intercepts. So anytime you see a word 0, roots, x-intercepts, or it could say solutions, right? Solutions to the equation. That is all talking about the exact same thing. Where does it cross the x-axis? And then it says list from largest to smallest. And so from this term in the front with the n squared, it crosses at 0. And then from this term, n minus 6, it's going to cross at 6. Unless it says x-intercepts, you do not have to put them as coordinate points. So this will just be 6 and then 0, largest to smallest. And you don't write them as coordinate points unless it specifically asks for x-intercepts. Multiplicities are the powers on these zeros. So when you have different multiplicities, your graph is going to behave differently at those zeros. So this 6, the one in the front, it has a power of 3, so its multiplicity is 3. When it says respectively, it means go in order. So whatever order you put them in here, you put them in order here, the same. The 0 was in an n squared, and so its multiplicity is 2. In terms of multiplicities, this is going to be something you'll definitely want to have written down. In terms of multiplicities, if it's an odd multiplicity, it's going to cross the x-axis. If it's an even multiplicity, it's going to turn when it hits the x-axis, or what I like to say is it bounces off. It bounces off. So these zeros, if you're looking at a graph, like let's say you have this one, they're going to cross through. If you're looking at an even one, your graph is going to come down, hit it, and bounce off. So it's not going to go through that 0. So this is important information to have. Multiplicities, if they're odd, that's going to cross. If it's even, it's going to turn around, it's going to bounce. It doesn't ask us specifically what's happening at those zeros for this one, but it is on the next question. So make sure you get that written down in your notes.